Physics in badminton.
There are three objectives here. First, to know how a projectile motion involved in badminton game. Second one, to solve inelastic collision in badminton using principle of conservation of momentum. And the last one, to find out the impulsive force that act on the shuttlecock in a certain velocity.
Before we continue, there's a few concepts that we need to know. First of all, projectile motion. Projectile motion is a motion of an object launched to move in air under the influence of gravity only, where there is no air resistance. Next, impulsive force. Impulsive force is when large force is exerted on an object over a very short period of time or vice versa. Lastly, an elastic collision is a collision where the momentum is conserved but not the kinetic energy. However, some kinetic energy is converted into other type of energy or lost to the surroundings. Based on the concept involved, these are the formulae that could be applied in problem solving. First of all, we have the linear motion formula in kinematics. It can be divided into x direction and y direction. Since we are only interested in projectile motion, the acceleration in x direction will be equal to 0. While in y direction, it will become g acceleration negative 9.81. The velocity will be constant at all times. However, at the highest point of the motion, the velocity in y direction will be equal to 0. Next, we have the impulse, which is F into mv minus mu, and impulsive force, which is Fv minus mu over t. Based on this formula, when the time of contact is low, the impulsive force produced will be high. And lastly, based on the principle of conservation of momentum, since this is an elastic collision, the formula will be mu plus mu equal to mv plus mv, where the velocity after the collision will be the same.
The first principle applied in badminton is inelastic collision between the racket and the shuttlecock. When the collision happens, the momentum is conserved but not the kinetic energy. After the collision, the speed of shuttlecock is decreasing. A portion of its momentum is retained, which makes it move away from the racket. The second principle is impulsive force. When the racket strikes the shuttlecock, an impulse is applied, changing the shuttlecock's momentum. Next, projectile motion is applied on the shuttlecock. We can calculate the time of flight, the maximum height, and the horizontal distance that the shuttlecock has traveled.
A badminton player hits a shuttlecock of mass 5 gram moved from rest with velocity of 20 meter per second in 0.1 second. Calculate the impulse delivered to the shuttlecock. Then calculate the impulse force act on the shuttlecock. So V equal to 20 meter per second, U equal to 0 meter per second, T equal to 0.1 second, M in kilogram equal to 0.005 kilogram. So for impulse, the formula is M in bracket V minus U. So insert the value and the answer is 0.10 Newton second. For impulse force, the formula is M in bracket V minus U and the answer divided by T. So insert the value and then the answer is 1 Newton.
For the next question is about inelastic collision. So the question stated that a badminton shuttlecock with a mass of 5 grams and an initial velocity of 10 meter per second collides with a badminton racket. The racket with a mass of 200 grams moves towards the shuttlecock with an initial velocity of 2 meter per second. If the collision between the racket and shuttlecock is inelastic, what is the final velocity, V, of the shuttlecock? First of all, we need to list out all the information given in the question. For the first one, the shuttlecock mass, which is M1, which is 5 gram, is equal to 0.05 kilogram. Next, for racket mass M2, 200 gram is equals to 0.2 kilogram. Initial velocity of shuttlecock U1 is equals to 10 meter per second, and initial velocity of the racket U2 is equals to 2 meter per second.
So, how to solve the question is by applying the principle of conservation of momentum in the direction of the collision, considering the inelastic nature of the collision. We will use the formula of inelastic collision, which is M1 times U1 plus M2 times U2 is equals to M1 plus M2 times by velocity.
So now, we will insert the value of M1 and U1 into the formula and also the value of M2 and U2 into the formula. And we will get the final velocity of the shuttlecock, which is equals to 2.20 meter per second.
Hits the shuttlecock with initial velocity of 20 meter per second at an angle of 30 degree above the horizontal. Calculate first time of the flight, second the maximum height reached, third the horizontal distance covered by the shuttlecock. We know that the initial velocity is 20 meter per second and the angle is 30 degree. So first of all, we need to break down the initial velocity into x and y components. For the y components, we got 10 meter per second, and for the x component, we got 17.32 meter per second. The first question, we're going to use the formula of Vy equals to Uy plus Gt. At the maximum height, this is actually equals to 0. So we're just going to substitute all the values into the formula, and then we got t equals to 1.02 second. And then we actually need to times with 2. So we got 2.04 second. And then the second question, we need to use the formula of Vy squared equals to Uy squared plus 2GSy. We know that Vy equals to 0 at the maximum height. We just substitute all the values into the formula, and then we got Sy equals to 5.10 meter. And for the last question, the horizontal distance, we need to use the formula of Sx equals to Uxt plus half Ax t squared. Just substitute all the values, and then we got 35.33 meter.
Now we had reached the last page of our slide. To sum up, there are a lot of physics concepts that involve in badminton game. For instance, in solving impulsive force problem, you could use this formula. For inelastic collision, you need this formula which apply principle of conservation of momentum. And the last one, we could conclude that projectile motion involved in badminton because when the shuttlecock launched to move in air, only the gravity influenced the motion and we ignore the air resistance. So that's all from us. Thank you.